This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
When your computer starts finishing your sentences before you even finish typing, you begin to wonder, is it magic, or is the machine secretly watching every move you make? That uncanny feeling is exactly what OpenAI's new computer history feature delivers, turning your desktop into a silent teacher that records every click, keystroke, and window switch, then feeds that stream of behavior into the same large language model engines that power ChatGPT. The first thing to understand is what lies under the hood of this seemingly simple convenience. Computer history is not a clever macro recorder, it is a lightweight telemetry layer that lives alongside the OpenAI desktop client. Every time you move the mouse, launch an app, or edit a file, the layer timestamps the event and writes it to a local log. When you summon the assistant, the client bundles a concise snapshot of the most recent activity, say the last 30 seconds or a minute, and sends that tiny narrative to OpenAI's inference endpoint. The model then treats this snapshot as a dynamic prompt, merging the usual, "you are a helpful assistant," instruction with a short story of what you were just doing. Imagine you are drafting a proposal in Pages, then you flick over to Numbers to check a sales chart. The assistant can infer that you might want to embed the latest figures, and it will offer to pull the relevant cells directly into your document. In code, a developer who just edited a function in VS Code might see the model suggest the next logical test case, based on the recent edits. The entire experience feels like the assistant has a short-term memory of your workflow, allowing it to generate responses that are anchored in the concrete context of the moment. Early adopters quickly notice the productivity boost. Routine tasks that used to require manual macro creation start appearing as proactive suggestions. A marketer who repeatedly copies rows from one spreadsheet to another after updating a column might see a prompt that says, "Would you like me to automate that copy and paste step?" A novelist who pauses halfway through a paragraph can watch the AI finish the sentence in a tone that matches the preceding prose. Developers report code snippets auto-filled based on the most recent edits, cutting the time spent searching documentation. But the magic is not uniform. The system's usefulness hinges on the fidelity of the captured data and the model's ability to interpret it correctly. When the model misreads intent, it can become intrusive, offering to send an email you were merely reading, or suggesting a file move that disrupts your current task. The feedback loop that decides whether the assistant is helpful or annoying remains opaque. Users have little insight into why a particular suggestion appeared, and there is no simple way to correct the model's misunderstanding in real time. In short, the promise of a hyper-personalized copilot is tantalizing, yet the reality still feels like a prototype that occasionally oversteps. But here's the part most people get wrong: the convenience comes with a hidden cost that goes far beyond occasional annoyance. Every keystroke, every password field, every snippet of confidential code becomes part of a data stream that could, in theory, be used to train future models. OpenAI assures users that the logs stay on the device until a query is made, and that only a concise snapshot is transmitted. Yet even a short snapshot can expose sensitive information. A glimpse of a password entry, a snippet of a legal contract, or a line of proprietary source code can be enough for a determined analyst to reconstruct private details. From a regulatory standpoint, OpenAI now acts as a data controller for each user's workflow, which triggers obligations under GDPR, CCPA, and emerging AI governance frameworks. Users must be able to audit what has been sent, delete their history, and opt out without losing core functionality. The current UI offers limited visibility, often just a toggle to disable the feature, leaving many users unaware of the breadth of data that could be harvested each time they ask for help. The business incentive behind this data capture is clear. The richer the personal context, the more valuable the assistant appears, driving higher subscription rates and providing a continuous stream of real-world usage data to fine-tune models. Critics argue that this creates a subtle exchange where users trade their behavioral data for convenience, without any direct compensation for the raw material that fuels the next generation of AI. Enter ChainMind, a decentralized AI inference network that proposes a different way to get the same contextual assistance without surrendering raw data to a single corporate endpoint. In the ChainMind model, inference workloads are spread across a peer-to-peer mesh of nodes owned by independent participants. Instead of sending your activity log to a centralized cloud, the assistant can run locally on your machine or on a trusted edge node you control. The context, your recent clicks, the file you're editing, remains on your device, and only encrypted, abstracted shards of the inference request travel across the network. Multiple validators process these shards, and the result is reassembled without any single party ever seeing the underlying activity. This architecture embodies the principle of data minimization. You keep sovereign control over your digital footprints, and you decide explicitly when and how to share any piece of it. For a law firm handling confidential case files, a ChainMind-enabled assistant could suggest relevant precedents without ever exposing client data to an external server. In healthcare, a physician could get context-aware suggestions while drafting patient notes, with protected health information staying behind the clinic's firewall. Even for everyday users, the knowledge that your personal workflow never leaves your own hardware can be a compelling differentiator in an age of growing privacy awareness. Of course, decentralization brings its own technical challenges. Latency is the most noticeable. When a request has to hop across several nodes, especially for a model the size of GPT-4, the response time can stretch beyond what users expect from a real-time assistant. ChainMind tackles this by employing model quantization, reducing the precision of the model's weights to speed up computation, on-device caching of frequently used model fragments, and adaptive routing that prefers the nearest high-capacity node. The network incentivizes node operators with token rewards, ensuring that sufficient compute power is available when demand spikes. Another hurdle is maintaining model consistency. Centralized providers can push a new version to all users instantly, but a decentralized network must coordinate versioning across a heterogeneous set of participants. ChainMind addresses this with a governance layer where token-based voting decides which model snapshots are promoted network-wide, balancing rapid iteration with the stability required for enterprise use. These trade-offs illustrate that a privacy-first approach is not a free lunch. It demands careful engineering, economic incentives, and community governance to deliver a user experience that feels as seamless as the cloud alternative. Beyond the pure decentralization approach, there is a promising hybrid path that blends the best of both worlds: federated learning. Imagine training a lightweight personalization layer on your own device, using only your local activity logs. Periodically, the device contributes anonymized gradient updates, mathematical representations of what the model has learned, without ever sending raw logs. These encrypted updates are aggregated by edge nodes, then merged into a global model that improves for everyone. OpenAI could retain its centralized inference service, but the personal context would never leave your hardware. ChainMind is already experimenting with such hybrid schemes, where edge nodes collect encrypted updates from participating devices before forwarding them to a secure aggregation server. The result is a model that benefits from the collective intelligence of thousands of users while preserving the privacy of each individual's workflow. This approach could satisfy regulators demanding clear documentation of data sources and human oversight, while still delivering the hyper-personalized assistance that users crave. So where does this leave the everyday worker, the developer, the writer, the analyst who just wants a smarter desktop? The choice comes down to trust and trade-offs. If you are comfortable letting a single provider collect granular snapshots of your activity, confident that their privacy policies and regulatory compliance will protect you, the OpenAI computer history feature may feel like a productivity miracle. If you are wary of handing over every keystroke, especially in regulated industries like legal, finance, or healthcare, a decentralized solution like ChainMind offers a path where the assistant is still powerful but your raw data never leaves your trusted environment. As governments tighten AI governance, think of the EU's AI Act requiring explicit consent, impact assessments, and clear documentation. Services that fail to provide transparent data handling may find themselves on the wrong side of compliance. Conversely, platforms that embed privacy-first design patterns, local-first storage, granular consent, ephemeral snapshots, and transparent auditing will likely gain a competitive edge as privacy-aware consumers become more discerning. In the end, the technology itself is neutral. It is the architecture and governance choices that determine whether a desktop assistant becomes a trusted partner or a surveillance tool. OpenAI's computer history is a bold step toward contextual AI, but it also shines a spotlight on the tension between convenience and privacy. Decentralized inference networks like ChainMind demonstrate that we can have both intelligent, context-aware assistance without surrendering control of our digital lives. The competition between centralized and decentralized models will shape the next generation of AI-enhanced workspaces, and the winners will be those who put user agency at the forefront. If you want to stay ahead of this shift, keep an eye on the evolving standards for transparent AI assistance, explore tools that let you audit and delete your activity logs, and consider joining the movement toward decentralized AI. Follow ChainMind for the latest updates on how a peer-to-peer mesh can give you the power of a personal AI copilot while keeping your data truly yours. Your workflow, your data, your choice. Let's build a future where the computer truly becomes a teacher, not a watcher.